Hello guys, today we are going to look into what is DSP. To understand what is DSP, first we need to understand what is DSP. DSP is a branch of engineering where the digital signals are being processed. The techniques and the filters that are required for the digital signal to be processed are being studied in the DSP. So to understand these signals and the processing that is been taken care, first we need to understand what are signals. There are two types of signals. One is digital signal, another is analog signal. So analog signal are are the signals that we are seeing in our daily life, like the speech I am speaking right now, the electromagnetic waves, the light, and everything are analog signal. This analog signal cannot be understood by the computer. To make them understand these signals, we are converting these signals into a digital format. That is by taking the samples of these signals and converting them into a digital format. That means if in analog signal is continuous in nature, and there will be a lot of infinite number of samples present in a single second, whereas in digital signal there are finite number of samples in a single second. So uh, uh, these finite number of samples can be stored and can be processed. So the process of converting this analog signal into digital signal is called as sampling. I'm not going to go deep into this sampling and the DSP concept right now. I'm going to show you how a sine wave signal can be stored into a digital format, and how the digital signal are being stored using a C program. So this is a C code I have written to convert analog signal, that is a sine wave, into a digital signal. So first, to convert a sine wave into a digital signal, first we need to have some certain values, and we need to declare them. So I'm going to sample this sine wave with 44100 samples per second. That means I'm going to have a 44,100 samples per second. So this is the standard audio sampling rate. That's why I'm taking it. And if you want to increase the sample rate, the quality of the audio will increase, and which is not required for this particular example. So I'm going to keep the standard as the standard value. So the duration is the length of the wave file that is required is a duration. So I'm taking 5 seconds of data, which is sufficient for the example. And the amplitude is something to which we are going to multiply the sine value. So is 32767. Why 32767? The highest value that can be stored in a 16-bit integer value is 32767, and the lowest is minus 32768. So it is my bound between 32767 and 32768. So to make this bound between 32768 and minus 3277, we are taking 32767 as the standard value. And coming to the metadata here, this is the metadata that is required for the wave file. So to make the computer understand some properties of this wave file, we are going to it has to contain this metadata, and every file format and every file consisting in our PC will be having this metadata, which is required for the computer to understand the properties and the application which it can be opened with. To understand more about this audio formats and different kinds of audio formats that are present um, in audio, please let me know down in the comments, and I'll make a detailed video of different audio formats and their metadata, and how these audio formats differ from each other. So this function is required to write this metadata uh, into the wave file. So coming to the main function, here I'm opening a file pointer, f file, and I'm opening a sine wave file with write access. So if there is an error opening this file, I'm going to get a return status as 1. By this we get to know that there is an error with this wave file. I'm taking a number of samples. The number of sample is the value that for which the for loop will get uh, looped for number of samples of time, so that we will be having this many samples. So for this example, we are taking 44100 into 5. That means we'll be having 2,20,500 samples in the wave file. So the for loop will be run for 2,22,000, and each time this process will repeat itself. So in this for loop, I am defining a double sample value with a data type of double. The sine wave values will be always in points. That means 0.01, 0.17, or it will be around minus 1 to plus 1. So to store this kind of data, we need to have either float data or double data. Float will be very less in size, so I am taking double data type as a standard. So so in the sample value, I'm going to get a sine values with 5,000 frequency. This is a sine. So in this, the sine value is consisting of 5,000 frequency, 2,000 frequency, and 2,000 frequency. So I'm adding all these values and putting it into the sample value, and I'm dividing it with 3, and so by that I'm getting a average value of these 3 sine values. And after getting the average, I'm going to multiply with the amplitude. And after multiplying with the amplitude, we'll be having this sample value, and I'm converting this sample value into a 16-bit integer so that it can be stored into the file wave. So if right, we're going to write these values into the file. Few values like number of samples are not yet defined in the initial stage. So we are going to we are going to fill these values in the header file, and for that I took the file pointer to the initial point and filling the number of samples using wave header right into wave header function. So after that, I'm going to close the file and print the success statement. To run this code, I'm going to open the terminal in the DSP1 folder. In this, I'm going to press enter gcc main dot c dash o dash o. That means output, and main will be our output file name. So after pressing enter, I'm going to get a main.exe here. So to run the main.exe, I'm going to enter it into the terminal. So only after running the exe file, we are able to generate the sine wave. So you can see the sine wave is been generated. So if I open the sine wave, you can see this is the audio. So this is a signal we have generated. So to take a better look at it, we can open this in the Audacity. Audacity is a software that is where we can see our wave files in a detailed manner. So I'm going to import this wave file. As you can see, this is our generated file. If I zoom in, I'm able to see the frequencies and the sine values. So as I'm using multiple frequencies, this will be like this. So to see the frequencies what we have implemented, to verify whether they are present or not, we are going to plot the spectrum for this. As you can see, this is consisting of three frequencies, and each frequency, first one is at 1000, and the second one is at 2000, and the third one is at 5000. So that means our output and the input what we are given is matched, and this is how a analog signal is converted into a digital signal and stored in a wave file. So in the same way, every analog signal are being converted into digital signal. This is how a analog signal is converted into a digital signal and stored in a wave file using C. So thank you for watching the video, and see you in the next one.